multi-hazard assets, but also require constructing a comprehensive reference data repository. Another bottleneck here is the heterogeneous data without standards to follow. So most of the time, the data is of different formats and variety of providers. The first problem we met when grasping the data is how we put them together in one platform. The second problem we usually met is the performance limitation when it comes to process and demonstrate a great quantity of heterogeneous data. In this project, we're trying to establish a platform for authorities to make the evacuation decision based on environmental basic information, monitoring data, damages news, warning references, and weather conditions. All this data comes from different government units with different data formats and content. Some already publish the web services, even WMS or SOS followed by the OGC standard, while the other may yet developing such service by providing the KML or KMZ file, or just offer the file raw data. So under limited time and resources, we put our goal into two phases. The short-term goal is to try to grasp all this data based on original way the data offered, and integrate it into one platform for initial references on decision making. So under such condition, we categorize all this data into 4 types. The WMS for GIS data, SOS for monitoring data, web services, KML or KMZ, and the data connections. Then we try to retrieve the web service data and import to our own database for advanced query or spatial data analysis. And finally, we offer a platform for decision makers to query, to organize in layers, or to check some statistics data from several government units to make the initial judgment for local evacuation decisions in some damaged area. The system includes the customization tool to manage the scene layers and web services, and the basic environmental information, weather condition, warning systems, and real-time disaster news are all provided through this platform. With the customization tool, the decision makers can customize their own scene layers and save as the scene group. Also, decision makers can change the retrieving frequency of web services and detect if the web services are working well. Some monitoring data like surveillance video is published by SOS, and other data like rainfall or geophone frequency are transmitted from each monitoring stations can be shown on the platform. And in this platform, we collect disaster news from internet media through RSS, the road and bridge damages, and flood warning by web services from Directorate General of Highways and Water Resource Agencies. During the typhoon season or the storm period, the system focuses on the disaster or damage around the whole island. As I mentioned, one of the purposes of this platform is to take concern of local evacuation actions. So after we collect relevant data, we have some spatial analysis and provide some statistics based on the location of the evacuation shelters. We can tell if there are any debris flow warnings, possible flooding, or transportation breakup nearby the evacuation location. And decision makers can be noticed if there are some places needed rescue or material supply. Here we can see the reservoir information for flood discharge or flood warning. As to the weather information, we get and display the rainfall data from the Central Weather Bureau. During the typhoon period, there are typhoon path predictions by several countries. These paths can show on the platform, and historical typhoon paths can dynamically display on another monitor screen for comparing the similar path. All this this GIS data can be compared in two screens, and here's the demonstration. The platform is based on the Google Earth, by which we convert the data we get into CanML or CanZ format. The platform offers two screens side by side. You can load one imagery in the left screen and load the different layers in the right screen. Two monitors will move synchronously with the same area of interest. For example, you can compare aerial photo of the same location in two different time periods synchronously to check the differences and changes, and when the disasters occur. The weather is one of the critical factors that we should take into consideration. If we want to look up several prediction models or satellite or LiDAR images for references at the same time, we can load the satellite images or weather forecast maps to show the weather condition. And for the decision-making support, we can check the attribute data and the spatial location. In one scenario, we can check where the debris flow warnings area is, and if there are any evacuation shelters nearby. Also, if the transportation is breaking off, we should notify the residents to stay in the shelter and wait for rescue or supply. In second scenario, we can find out village which is in the flooding area or debris flow warning area. We may take evacuation actions and follow up. We can also check the on-site monitoring data from each monitoring stations. We built some models in the Google Earth and make the link to the equipment and the monitoring data. The on-site information such as surveillance video for the spot condition, the rain gauge, drill phone, and microclimate information. For now, there are 17 debris flow monitoring stations all around Taiwan, and we can get all this data through this platform by just one click.